Hey everybody, welcome back to the channel. So today I'm going to be teaching you guys how to make a neural network in C#. If you don't know what a neural network is, I'll be putting that link in the description so you can go figure out what a neural network is. But if you don't care enough, or if you already know, then yeah, we'll get right into making it. So what we're going to be doing with this neural network, I've just followed this video, except the video doesn't really show you how to program at all. It just explains how neural networks work. And all you really need to do is watch the first part of this series. It's a series. You could watch like the first two videos or the first video, and then you'll be good. If you really want the in-depth understanding, that's what you could do. And then yeah, I mean that's like really the only link that I'm gonna be adding, except for I'll also add another link. Yeah, I'll be adding a link to my data set as well that I made, and all it is a bunch of pictures you could download. Like I only have 32 here, but I made a lot of 128 of the first four numbers. But yeah, because what we're doing is making image recognition neural network, so you're gonna be able to you're gonna be able to draw a number like that, or like that, or like that, or like that, and then what the application will do is it will give you a number response in text. Like it will be able to detect what number that you drew. So if I draw 3, it'll be able to tell me I drew a 3. And so on, so forth. But regardless, let's get right into it. So there are going to be a few discrepancies from my neural network compared to a lot of other neural networks, and a lot of videos explaining how they work, but I will be explaining how I made mine the best I can. So let's just get right into this. We're not going to be doing much with this class, at least for now, but I will just set it up how I like it. So the first thing we're going to do is create a new class, and by the way, I am using Sharp Develop. You can do the exact same things with the Visual Studio. So go to your project at the top of your screen, and then add new item. You can't see me doing it, but it's add, and then you click on add, and then it should say new item. You can add in a new class now, and add in a new class called neural network. Do the same thing, and make one for neuron. And your neuron class, this is the most simple class we'll be making. It's gonna have a public byte activation, and most people's activation are 0 through 1. Mine is the exact same thing. Like people have their activations like it's a decimal, like that. 0 through 1. Mine is the same thing, except it's 0 through 255. It saves memory because you have a lot of neurons, and it's convenient because pixels are stored in bytes, 0 through 255. So it's very, very, very easy to convert it. And yeah. The other thing we're gonna do is make our bias as byte. That's the same thing as a byte, except it goes -127 through 127 or something like that. It'd actually be one different than that, but it's similar to that. And then we also make a public single, which is the same thing as a float, and then call it toDescend, because it is basically the error of the network. It's how much we're going to be changing the neurons connections or weights and biases by, and you'll kind of see it later. And to initialize our neural network, what we have to do is get the layer lengths, and uint16 is the same as a ushort. And if you don't know what a ushort is, it is a number that's 0 through 65535. And the reason that we're using that is because we want to save as much memory as possible, and no network is going to have a layer under 0, and hardly any are going to have a layer over the length of 65,000 neurons. Definitely not ours, because if it did, then it would be very slow. And I'm not trying to wait 10 hours. And then we'll store that data in a variable. And we'll, so just for ease of access, we'll store the length of layer data. There's no real purpose to it. We just need to just so that we could use it to make calculations in the future more easy to read. And just so that we're clear, neural network, and the purpose of layer lengths is so that you know what the sizes of the layers are. So the images that we're working with are 33 by 33, all of them. So that means that the area is 1089, so there's going to be 1089 pixels, so that's how many neurons in the input layer we're going to have. And then the hidden layers, I found 17 to be the best for this kind of thing. And then the output layers, if you want to do 10 numbers, it'd be 10, but for this video we're doing 4 because I want to be able to just quickly show the neural network working, because if you do 10, it's going to take a long time to learn. It's going to need different adjustments that'll make it even longer, and I just want to be able to quickly show that it works. Certainly, instead of running into error like, oh, this didn't work and we waited 5 minutes for it to learn, so we have to restart. I don't want to go through that, so we're gonna just do 4 numbers for the purpose of the video. 4 digits. And yeah, let's just get back into this work. We're going to create a private static random. And the reason we're making it private static random is because if you weren't aware, randoms are based on timestamps. So if you make 2 randoms at very similar times, then they're gonna give you the same values if you try to get a random number from them. So the way that you fix that is you just make it right there as a static instead of putting it in a loop or something. And then we're actually gonna make the list of layers. And before I explain what I did there, we have to import a few things. System.collections are generic just to get the lists, and then I can't live without link. We need to use it, so we're importing it there. And just to quickly explain what the logic behind that is. Say that I have this neural network and these are my neurons. I know that it's not like up to scale, but say that this is it. The first list is all of these. So if I did layers 2, for instance, I would be accessing a list of all these neurons. Hence the list neuron. And then, for example, if I did list layers 4, then I would be accessing 0, 1, 2, 3, 4. I would be accessing this because 0, 1, 2 is 2, and then 0, 1, 2, 3, 4. So I'd be accessing this one, and that's the logic behind that. We also want a constant learning rate. I call it descent. And it's gonna be really low. And we set f right there so that it's a single, which is the same thing as a float. I already said that, but. And then the final thing we need to do is the connections. Okay. Oh. What is all this about? Oh. There we go. Now we have to. Oh, right. So the logic about weights, this weights matrix, is that you can input any neuron in this dictionary, anyone, no matter what layer it's in, and then you're gonna get a dictionary containing every single neuron that it's connected to. So, for example, say this neuron, for example, it's connected to this one, 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 this one. So if I selected this one in the dictionary, it would give me all of these ones because they're in the next layer. And if I selected like this one, for example, then it would return this one, 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 and this one. And what it would return is not only the neurons, but since it's a dictionary, it also returns the value of the weights, which is the connection between all of them, like that. and we'll initialize everything here. Now we're gonna need some counters. We're gonna name them I and J because I is or J is after I in the alphabet. The reason that I is a byte is because it's gonna count the amount of layers, and that's not gonna be higher than 255. So to save memory, we put in a byte. And you'll notice that's a common trend that I do in all of my programming. And as I said, we're looking through every single layer, so we're gonna put layer count. And then we're just initializing everything. So although we may have initialized the list of list neurons, we haven't initialized all the lists inside of it right here. And we're gonna set the capacities because we might as well, because we know what they are. Not this one though. This one would be a lot of math to do, and I'm not prepared to do it on the spot. But back to this. This.layers.add neuron, and then the way that we initialize a neuron is by without a okay, wait, we're not initializing the neurons yet, my bad. But what we do have to do is initialize the capacity. And the way that we get the capacity is we put all the capacities in the layer data. Because it's the lengths of the layers, and right now we're creating all of the layers. So we have to get the length of the layer. And as you remember, it's the length of the layer. And now we actually have to add the neurons in the layer. And that's what we're using J. And now we actually have to create the neuron without a constructor. And the way we do that, we're going to set value to 0 to begin with. Bias. Now, we could potentially randomize the bias, but we're going to initialize it at 0. I've had the most luck with that. And then 2% is actually also going to be 0, so we really didn't have to do that. But I guess now if we have to change it, it'll be easy. Now we'll increase J, and for every time it loops through, we're going to obviously want to increase I and set J to 0 so that it's prepared for the next loop. And then now we have to loop through every layer except for the output layer, because we're going to now be making the connections, the weights. As you can see, the output layer has no connections. It can't connect to anything. So we're going to skip that by saying this.layer count reduced by 1 to get rid of the output layer. That's why we're reducing 1. And then go through every single neuron in that layer. And then, just like the logic that we had here, we're going to initialize the dictionary. And the connections are going to be equal to the next layer. Because let's say that we're getting the connections of this one, we're going to need to get the size of this, because that's how many connections it's going to have, which is the next layer, and that's why we're doing j plus 1. And now we actually have to make the connections, so we're going to loop through the next layer, j plus 1 again. And select this neuron and give it connections equal to every single neuron in its next layer. And we're going to initialize its weight to some random value between negative 0.5 and 0.5-ish. Except we want it to be low to begin with. And the reason we want it to be low to begin with is because we need the neural network to have like space to breathe, and for lack of better words, because I have a limited vocabulary, but basically we don't want to set really high. We wanted the neural network to learn, and then it will be somewhat high after it learns what it should be. And the way that we regulate that is we just divide it by 10, and that will just move its decimal place down by 1. And that's it for that. And then we just have to increase j. We didn't do that. And I used I here. I could use I, but like, there's no difference if I use I or j here. I'm just gonna use j because we've already used the memory, so we might as well use it again. It's less limited, even though we're not gonna need it. And I completely forgot to put in. Let me see if everything's fine. No overload method for add takes 1 argument. Forgot to do that, I believe. There we go. Now, believe it or not, we've already initialized the neural network. We have our entire structure done. Now we only have to create the function that moves everything to the right. So, you get the input, and then it moves everything to the right. And then we also have to add learning and stuff like that. To start off with, we're going to make a public list byte make prediction. And we're going to have the input values, desired answer, whether or not you want it to actually train or not, whether or not you want it to visualize, and what you want to do when neural network fails. And the neural network fails sometimes because its weights get out of whack, or not its weights, its biases get out of whack, and they're like above 127 or below negative 127. And that could happen sometimes, and it's a problem with a neural network. It happens on occasion with everybody's neural network that I know of. I just was looking around on Stack Exchange when I had that problem. I thought it was an issue with my neural network, but it turned out that it was a common problem, and all it meant is that you have to adjust your training data, or your it varies from situation to situation, but sometimes your training data, sometimes your hidden layer length and whatnot. For me, it was a combination of everything. It was even the size of the images that I had to lower down. That's why I actually ended up making my own set of images, but regardless, let's continue. We're gonna go through every layer apart from the first one. And the reason we're going through every layer is so that we can set its activation to 0, just to make sure everything is set to 0. It doesn't interfere with our calculations. I don't think it will, but I'm not gonna risk anything here. And I'm gonna actually restructure the input here. because right now it's an IEnumerable, and with IEnumerable you can't do something like that, for example, and we need to be able to do that. So the simple way we do it is we just change it to a list. However, if it already is a type of list byte, then all we have to do is cast it. We don't actually have to convert it. But if it isn't, then we do have to convert it, which is simple. It just takes a little bit more processing power. And in the constructor list byte, you could put in any IEnumerable of bytes, and then it will try to create the list of it. Now we want to fill the input layer. That's why we actually skip this one, because we're setting the activations for the input layer here. We're gonna create a counter, and while it's less than the size of the input layer, then select the input layer, because it's always the first layer, and select the neuron that we're on, which is being tracked by the I variable, and set its activation to the input that we just restructured, and the corresponding activation value, and then increase I to go to the next neuron. Reset I because we're going to use it later, and we're also going to create a variable. Create a variable sum, because we're going to be creating a sum. And we're going to do the same thing, except this time, or we're going to be going through every single layer apart from the last layer, the output layer, and we just get rid of it by subtracting 1 from layer count. That's how we ignore the last layer. And the reason we're doing that is because the last layer doesn't have any. Actually, it's the exact same thing we did here. The last layer doesn't have any connections, so we're just skipping it. The only thing is we're doing it reversed, and the reason we're doing it reversed is because we have to get this, and when we calculate it, we have to we have to go in reverse like that, because we can't. I mean, we could do it the other way around, but this way is just easier for me, so we're just doing it this way. And we're going to increase the sum by, this is where the calculations begin. You want to get the activation of the neuron that's behind it, but we're going through every single one. Like, say we have this one selected, we're getting this one's activation. That's what neuron 0 is representing, and neuron 0 is also going to loop through every single one. And then this one here, whichever one I had selected, would be neuron. And we're getting its activation, and we're adding its bias, and we're multiplying it by the weight. Now we're gonna also half it, because we don't want it to get too high. Otherwise, it runs into the problem that I was describing earlier when I was just starting to make this method. Yeah, that looks fine with me. And now what we have to do is create a new class. util.cs. And the reason we're doing this is because there is a function that we need to make, well, a bunch of functions. But the first one is going to be, it's going to be a static class, because it's just util. And the first one is just going to be Sigmoid. And if you watch this video that I was talking about, you're gonna know what sigmoid is. The only difference is, instead of squishing it into 0 to 1, it's gonna be 0 to 255, because we're using bytes, not 0 to 1. And we can actually move it on one line, and we could do the same thing except make it go 0 through 1. All it would be it'll make it sigmoid f. All it would be is our sigmoid function except divided by 255. And then that would make it go 0 through 1. And hopefully that will help you better understand. It's basically the same thing, except 0 is 0, but 255 is 1. If that makes any sense. And now we go back to our network. And we can finally set the neuron's activation to sum.sigmoid, and then we can reset the sum so that it will be able to be used in the next loop. And now what we have to increase I. Now we did create some booleans like visualize and learn. If we do want to visualize, we're gonna have to do that later because not really concerned about it right now. But if we do want to learn, then we're gonna have to make a function. I'll do it right after this. We're actually almost done with this, believe it or not. Now we have to return the response, and the way we return the response, all we have to do is return the output layer. We're just going to give them all the values in the output layer, and so they can see every single decision that the neural network made, but only in the output layer, of course. And the way we do that is we go this.layers, this.layer count -1 to select the last layer, and -1 because to fix for 0 based index. And we're going to use link to only select the activation of it, because it doesn't actually need the other neuron data, it's useless. And then we actually have it set to return a list, because that's more easy to use than an IEnumerable. So, and it's not like we're yield returning anything, so yeah, we'll just return it as a list. Now, this is where we do the learning, and the only reason that we actually use these other two variables, desired and on fail, is because we're going to be passing them through to the backpropagate. Now the reason it's called backpropagate is because it goes from the output layer, it gets the cost of the output layer, and then it moves it back into the other neurons, going from right to left, hence backpropagate, because it goes from the back to the front. So what we're gonna do first of all is make sure that the to descend in every single neuron is set to 0, because that's the error of the, that's what's actually going to decide how much we change the neuron by. We want to make sure everything's set to 0 so that nothing accidentally sticks around and messes with our learning. And now what we're going to do is set the error of, set the to descent of our last layer. And we could just use link to select the last layer. It's very useful. And what we've done, desired answers is actually an array. So in the case of number recognition, you only want one answer, and that's the correct number. And as you can see, this would be the desired answers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say you wanted 4 to be the desired answer, for example. You would go 0, 1, 2, 3, 4, and you set it to 255 because that's the highest possible value. And you leave all the other ones at 0 because they're undesired. And then we're taking this and subtracting it by the output layer, which could be anything. It could be anything, whatever the neural network decides to come up with. And it's taking the fourth thing, and then it's subtracting it by this, and that's how it decides how much to boost everything by, while everything else is not going to get boosted at all because it's set to 0. Now we want to loop through every single layer again except for the last one, because we already did the last one. As you can see, we want to move everything, all the to descents from the last layer to the previous layers, hence backpropagate. The way we do that is we're going to subtract layer count by 2. 1 because we want to get rid of the last layer, and another one because we need a fix for a 0-based index. And we're creating a sum again. And we're just going to make a while true loop. And the way this is going to work, we're going to increase or decrease I because we're going backwards. But if I is equal to 0, then it can't decrease, and that's going to be our condition to break. We're going to go through every single layer, and we're going to get the layer in front of it. As well. And we're going to get the weight, because that's basically how much it contributed to the output, and then multiply it by how much it's supposed to descend by. And then set the to descend value. And this time we're going to use a Sigmoid f function, because we're not actually dealing with a byte right now, we're dealing with a single. To descend is a single. And what we've done is we've just set it to descent. We actually haven't made it change any weights. We haven't changed any biases. Now this is where the error could come in that I was talking about, where the bias gets too high or too low. So we're gonna try to change the bias according to the neural network descent, which is the learning rate. Multiplied by how much we need to actually descend by. But in the case that there is an error, it's pretty simple. All we want to do is make sure the user actually wants to do something. If it fails, because we don't, honestly, it's not that big of a deal, because no, we'll still go on. And if they do, then invoke whatever anonymous method that they want to run. Sometimes you want to print to let you know the network is failing, so you could restart it manually if you want to. Other times they have it automatically reset manually. You can have it print variables. And you can't forget to set the sum to 0f. Now here we're going to reuse the I variable because we don't want to use any more memory. So we're just going to set it to 0. And this time we're going to go left to right because we've already backpropagated. Now we actually have to set all the weights accordingly. We've already set the biases, as you can see. But we have yet to set the weights because it's impossible to set them like this because it does them one layer in advance, so we can't. We have to just do it now. And we don't, the last layer doesn't have any the last layer doesn't have any weights, so we get rid of it by just subtracting 1. And we're doing the same thing that we did here, just getting the neuron, and then getting all of the connections for the layer in front of it. Adjusted by the learning rate, multiplied by the activation divided by 255. And what's that gonna do is it's gonna, you can think of it as a percent. So let's say that it's 127. That's about halfway. So if I divide it by 255, it's gonna give me 50%. And if I did 255 divided by 255, it's 100%. And if I did 0, it's 0%. So you could think of it as just converting it into a percent, because 255 is always going to be the maximum. And then we're gonna just call in the how much it actually wants to get descended by. And the last thing we have to do is just increase I. And we're actually pretty much done here. We just have to do one more thing, and that's get the pixels of the images and actually convert them into a list of bytes. And each pixel has color value of if it's black it'd be 255, if it's white it'd be 0. That's why it's really convenient, because we can just select one of the RGB values and it'll give us we can just feed it directly into our network. have to actually import system.collection so generic. Okay. We also have to import system.drawing. So all you have to do is go to your references, right click them, and you're not going to see this, but just press add reference and then look for system.drawing. And then import it. And now you can import system.drawing. You can import system.drawing.imaging. You can import system.data. Actually, I think you could have done that before, but still do it. Bitmap image, and now we can select bitmap, which is how images get stored in C#. And here's where things get a little bit confusing. The first thing we're doing is getting the area of the actually, I don't know if we need to do this, but I will just in case. We're getting the area of the image, and that's very simple. All this is the image height multiplied by image width. Very basic math. Height times width equals area. And then we need to get the x and the y, because we're getting every single pixel, and they're both the x and y values. And then we have other checks that we need to do, such as checking if the x value has reached the furthest right side of the image. And we just get the width, except we subtract it by 1. And then we do the same thing for check, except we don't subtract it by 1. And it's going to be the height. Now, while y has not reached the bottom of the image, because that's where our check 1 is, then return a value at image.getPixel x, y, and now, as I said, we can select any of the R, G, or B values since we're working with black and white images. Now we have to check if we've reached the furthest right side of the image, because we've only checked if we've reached the bottom. If we've reached the furthest right side, which is our check 0, then set our x to 0 to move it back to the left, and increase our y so that it moves down by 1. Otherwise, increase x and move to the right if it's not, if it hasn't reached the right side of the image. The final thing we have to do is dispose of the image. And just to make this easier for us, what we're gonna do is accept a string file name. And all we have to do, for some reason, bitmap.fromFile returns an image. So we have to cast it to bitmap. And fn is just for file name. It's short for file name. That's why I named the string that. And yeah, this is pretty straightforward right up here. And we're done with the network. All we have to do is create a training sequence, and this is actually a little bit hard, to be honest, but or maybe a little bit tedious, but we have a lot of variables that we're going to be needing. So like we want to know when when it started, so we know how long it takes per iteration. And the way you calculate that is if you subtract 2 date times, it returns the time span. So we're gonna have to store it in a time span, so create a time span. We want to get the answers, so we might as well pre-create that variable. And we also want to get the directories that contain the data set. And yeah, we're gonna have to import system.io, using system.collections.generic. And of course, system.link cannot live without that. And this will be in our data set. And we will also create a string array for files, as well as the directories. We also want to create an array for the desired answer, because as you remember in our neural network, it accepts a byte array for the desired answer. We'll create a random up here for the same reason we created a static random in our neural network. Create a string array for the directory and file because we only want one individual one. We want to know how many training instances we got correct versus incorrect. And we want to know if the user wants to step through the iterations or just have them go automatically, and if they want it to be visualized or not. Now finally, this is where things get a little bit complicated. We gotta create a training, or just a train subroutine. And this subroutine is gonna be a while loop, and we wanna see if the user presses escape to stop the training. However, we don't want to wait for them to press the key. The way we do that is console.keyAvailable and console.readKey true. And the key that we're looking for is escape. So if they press escape, it's all going to end. And now we can actually start filling in these variables. We're going to use datetime.utc now because it's quicker than now, and we just want to get the time span. So that's why we do that. Desired answer. I'm only going to be doing 4 numbers right now. I already explained that, actually, yeah. So only gonna initialize that to 4. And then for the directory, we'll be selecting the first 4 directories, which will be 0, 1, 2, and 3. And that'll be our training data. I'm only going to include 32, and I'll include the dataset download, as I said earlier. So yeah, just a reminder, the dataset download is there. No malware, it's just images. Where was I? We also want to get the files. So we're going to get the files from one of these random directories after it selects a random one. And then we want to select the random file from it. Now that we have the file, we can get the desired answer by parsing the directory name. And setting that to the desired answer by maxing it to 255. And what it's doing is going through the directory, it's getting the number, and as you can see, I named the directories the number of the whatever it's called, the number of the digit's name, and it's getting this, and that's how it decides it. So make sure you don't change the folder name, because that's how it figures out what the number is, what the desired number is. And now we actually make the prediction using our neural network, and we're storing it in the answers variable we made, answers list. we're going to use that image to neural data function we made in our util. File from there. Desired answer from here, and here's how we set that. Now it's asking us if we want it to learn. Of course we do, at least for the training. Visualize it, we made a variable for that, and we can ignore the action on fail right now because we just want it to do nothing. And now we can get the time span since it made the prediction. Earliest time first. I mean, not earliest. Time closest to when you're calculating it first. And then we actually want to get the prediction as get the neural network's most confident prediction instead of just getting it as an array of all its answers. So the way we do that is we get the maximum number in its answers. And we get its index, so we don't actually just get the value, we get the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 instead of getting 255 or whatever. We do the same thing actually for the desired prediction. Except this time, the only thing we do is we just convert it to a list because so we can get the link values, or the link functions. If the prediction is equal to the desired prediction, then that means that it was correct, otherwise it was incorrect, and then we'll just print out all the data. Now I'm gonna make this r/w, which is right and wrong, and then we'll write the correct, and then put a slash in between that and the incorrect. And finally, what I'm gonna do is give it say how many milliseconds passed. And honestly, the slowest thing right now, with this low of layer sizes, is going to be the console.write lines. Console.write line takes actually an absurd amount of time to write. It's crazy. In a loop, anyway. Takes up an absurd amount of time. The last thing we're going to put in this loop is if the user is actually in step. Then we're gonna actually want to wait for them to press a key because they're stepping. So this time we're not adding key available, we're not adding read key true. Do the same thing. And then if this does break or this condition gets broken, then we have a new condition here. And in case this condition gets broken, we'll halt. And that can't get broken. And let's say the user escapes out of this. Because they just press their escape key, they'll escape out of this. They'll move to this. We're gonna get their response because they want to do something now. Let's say the user wants to continue what they were doing, or continue training, so we'll add both of those. Go through the train subroutine. All that's going to do is going to move them up here and it's going to start this loop again, and they can press escape to go back to this loop. If they want to stop, then we'll add break or stop. We'll just go to this halt function. I don't know why, but like it's best to add it there because you might as well. And if they want to start visualizing, then we'll toggle the visualize flag by setting it to the opposite of what it is, and then go to the subroutine again so it starts training. And if they want to start stepping again, then we'll do the same thing except for the step one. And then if they don't want to do any of that, then we're going to assume that they want to test if the neural network works, and they're going to put in a file to test it. So we're going to get the results in a variable called results. And we'll set this to the neural network.make predict. What did I call it? I'm not sure why it's not autofilling for me. I'll check after, but anyway, the same thing, interesting about it, except it's going to be the user's input that we're accepting this time. Don't know why it's not autofilling. And this time, we're going to set that to null and false because we don't want it to learn, we want it to work. And then we're going to set the visibility to whatever it's at, which is false by default. We're not going to make that today. I'll put it in the next part of the series I'll put in the second part. And now we'll just print the results. Hold on. What in the world is going on? Oh, okay, so there's one error here. Line 78, neural network.cs. Change that to layer. It accidentally autofilled for me. Did the same thing here. Oh. I messed that up as well. And I also forgot to put equal sign right there. Okay, back to what I was doing. Where was it? Oh yes, that's what I was doing. I'll write down every single result, but I'll also make it crystal clear what happened, and I'll do the same thing that I did up here, getting the desired prediction, or getting the prediction. Just get the max value. And yeah, this will loop indefinitely until the user decides to do one of these things. And see what happens. I'm not sure. Oh, what is wrong here? Oh shoot. Okay. See if 8. Okay. Yeah, okay. I forgot to put the data set in. I felt like I was missing something. Just open up your project in Explorer. And then go to your bin, debug, where this is, and then take in the zip file I gave you. And then drag it. create a new folder called dataset, and then drag all the folders in there, and then you should be left with this. Debug dataset. That's a little bit weird. It should be hitting. I'm sure that this is like a really weird issue. 0. Oh, okay, yeah, okay, my bad. I put get files, should we get directories? And this is a lot to take in. I have a few concerns with this. I'm just gonna take a look here. Okay, everybody, I found the issue. So if you go to your util, I forgot to put a F right here. I forgot to put an F right there. Util.cs, and then now it should work fine. Yeah, now it's a lot quicker. But you don't. I'm sure a lot of you don't really understand what's happening right now. But so I'll go ahead and explain this. Just make sure that you have this right here set to F. It's things like that kind of are really annoying because it doesn't really matter. But if I press escape, as you can see, it'll stop, and now I can explain what is happening here. So on your left side here, you have a you have an answer of 1, and this is what the answer should be. And it is just selecting random images from the data set. And then that's what it's being tested on right now. So for example, I've just pressed escape. I can now test something from the data set without it actually training. I'm not sure it's gonna work. It hardly trained, but yeah, it just thinks it's a 2. It doesn't really know. As you can see, it's very indecisive. It doesn't really know. But then if I continue and let it train a little bit, as you can see, it's getting more right than it is wrong, and it wasn't doing that before. So as you can see, it's learning, and now as you can see, it has not gone anything wrong in a while. So this is probably the peak of its prime. And now if I go ahead and test these zeros from the data set, it now detects them as being a 0. But now the real question is, if I make my own numbers, and I don't really know. I'll just put a 3. You gotta make, if you're doing this, you gotta make sure that it's 33 by 33. and you press escape to test it, by the way. And in order to test things like that, you gotta put it in the same file as the executable. And yeah, it didn't actually recognize it. Okay, well, I mean, it seems to recognize my zeros. 2s, it works fine. It recognizes my 2s. As you can see, it says your number was A, and then it shows you the number. And right here, it was indecisive between 1 and 2. But as you can see, most of the time, it is getting it right. I guess it's not really good with 3s. Okay, maybe not. Maybe. Maybe not. Maybe I was just messing mine up. Yep. So that's working. Try 1s. Nope. Maybe it's not strong with 1s, or maybe I'm unlucky. Okay, wait, I think I see what I gotta do. Yeah, and then it starts getting 1s. And I'd say for, I'd say for like 30 seconds that I trained it, it's doing pretty good. I'll let it go a little bit more. I'm gonna stab, and whenever it gets like 10 in a row correct, or more than 10, I'm getting kind of greedy here. Shoot. There. So it's gotten a lot correct in a row, so that means it's probably stable. And yeah, it didn't work. Okay, there you go. 3. So most of the time it's working, and you know it's not just luck because I'm getting it right. Now, how many times in a row? We'll see how many times in a row I could go before it says it's wrong. And as you can see, I'm doing like all kinds of different shapes. Like, if this gets detected as correct, I'll be surprised. Okay, like this was cut off half by this, cut off almost fully right there. But it got 1, 2, 3, 4, 5, 6, 7, 8 correct in a row. Now let's there's a 1 in 4 chance divided by 8. The chance of that happening is 3%. Let's see how many. Let's see if I can get it again. This time I'm gonna try with zeros. 0, 1, 2, 3. Oh, okay, that's unfortunate. Let's ignore that. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so yeah, 12 times in a row. 2% chance. 1. Let's try 1s. See, now it's suddenly gone to 1 out of the blue. Wonder what the chances of that are. This is a really weird one. Still works. 1 again. Works. You know, what I'm trying to say is, if this is luck right here, if anyone thinks this is luck, I have to be really lucky for this to be luck. And then I'm gonna do that, and it's got 1, 1, 2, 3, 4, 5, 6, 7. What are the chances it's now gonna say 2? Oh shit. Okay. Well, I guess it doesn't. Oh, okay. I think I see what I gotta do to get it to say 2. Maybe not, maybe not. But as you can see, it was saying 1s, and now it's saying a bunch of 2s after I started drawing 2s. You know, all I'm saying is that it might not be strong in 2s, but like, it's not a coincidence that it's now saying 2s a bunch of the time. Right? It's not a coincidence that it's now saying 2 a bunch of times, and now if I put this 3, it's gonna say 3 a bunch of times. 1, 2, okay, 3. You know, you get what I'm saying. Like, it wasn't saying 3 before, and then it just said 3 5 times. And let's see, when's the last time it said 3? Up here. And then it just randomly said it 5 times in a row when I started drawing 3s. Right? And then 0s. When's the last time it said 0? Oh, it just did. But now, when's the last time it said 0 5 times in a row? Is the question. And then when's the last time it suddenly said 1? And when's the last time it suddenly said 1 3 times in a row? Oh crap. See, 3 times in a row. Not even lying. 3 times. 3 times in a row. So yeah, what I'm saying is, it works. Sometimes it gets it wrong, but as you see, its predictability is like 80%. It gets it right like 80% of the time. And let's see, if I try to do something like stupid with my number, like I don't know. Yeah, I don't know. You have to really get it round, I guess, for the 0s. Okay, yeah. It just doesn't know what to do when I do that. But yeah, when I start making my 2s bigger, it'll get them like all the time. 3s, and then it starts. Okay, maybe it's a little bit inconsistent with the 3s. Oh, okay, I think I just have to draw the stem out a bit in the middle, and then it'll detect it. Yeah, that's it. That's what I was missing. Maybe that. Okay, still works. Right, like 1 2 3 4 5 6 7 8 times in a row. That's not a coincidence. And yeah, that's where I'm gonna end the video, guys. I'm gonna do visualization in the next video, so it's gonna draw it on the screen what the network values are. But I hope you enjoyed this tutorial, and I hope you guys can make your neural networks.